Systems of three linear equations with three variables can also be solved using elimination method. We use one of the equations to eliminate one of the variables in the remaining two equations. Those remaining two equations will become the equations with two variables only, which we solve using the elimination method. If possible, we will use the equation that has a coefficient of one of the variable 1 or -1 to eliminate that variable from the remaining two equations. So let's look at the example. We want to solve the system that consists of the equations 2x minus y plus z is equal 10, 3x minus 2y minus 2z is equal 7, x minus 3y minus 2z is equal 10. We can see that the first equation has two variables with the coefficient 1 or -1, so let's focus on those equations. Let's call them A, B, and C, the equations in the system, just to see how we will be doing the elimination. We'll use the equation A to eliminate variable y from the second equation. And to do that, we'll have to multiply equation A by -2 and add it to the second equation, which is equation B. So if we multiply equation A by -2, we obtain the equation -4x plus 2y minus 2z is equal -20. The second equation is 3x plus minus 2y minus 2z is equal 7. If you add this equation side by side, the y variable will be gone and we'll have -x minus 4z is equal -13. Or if we multiply it by -1, we'll get x plus 4z is equal 13. We'll do the same for the third equation. So to eliminate the variable y from the third equation, we'll multiply the first equation by -3 and we'll add to the equation C. So equation A multiplied by -3 is going to give me -6x plus 3y minus 3z is equal -30. And the equation C is x minus 3y minus 2z is equal 10. Adding those equations will eliminate the y variable and we'll have -5x minus 5z is equal -20. We can simplify this equation by dividing by -5 each term or both sides and we'll get x plus z is equal 4. So this is now our equation 3 and our system becomes 2x minus y plus z, this is the first equation, equals 10. This equation has not been changed. We change the second equation and now that equation is -x minus 4z is equal -13. And the third equation became x plus z is equal 4. You can see that the variable y was eliminated from the equation 2 and 3. Those equations are now equations in two variables that we solve using elimination. Notice that the coefficient of x are already opposite numbers, so if we add those two equations, the x variable is going to be eliminated. And we'll obtain -3z is equal -13 plus 4, it's -9. And dividing by -3, we'll get z equals 3. So we got the value of z. Now I will take that value of z and substitute to one of the equation, either 2 or 3. Equation 3 is easier to solve, so we'll have x plus z, which is 3, is equal 4. And therefore, that gives me value of x equal 1. We have value of x, we have value of z. Now we'll take the first equation that has all 3 variables and we'll solve that equation for y. So we'll have 2 times x, which is 1, minus y, plus z, which is 3, and this is supposed to be 10. So we'll have negative y is equal 5, or y equals negative 5. We have our numbers, and therefore we can say that the solution of that system of 3 equations with 3 variables is a triple of numbers. X is equal 1, y is negative 5, and the z is 3.